a sign from profound space, a planet that overcomes all presumption and a rush to another star. Imagine a scenario in which everything we assume we knew about the universe is about to be broken. The James Webb Space Telescope, JWST, has uncovered secrets so stunning that they could rewrite the rules of life itself. But is Proxima B genuinely another Earth or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as mankind's most advanced instrument in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered, Proxima B. This distant world, orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we are finally taking a closer look at this enigmatic planet, and the revelations are nothing short of remarkable. Proxima B was first detected in 2016, but it wasn't until the James Webb Space Telescope entered the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden from view. What they found has sparked both excitement and concern. You see, Proxima B orbits its star at an incredibly close distance, just 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf, unlike our Sun, which is a relatively stable star. Red dwarfs are known for their volatile nature, frequently emitting powerful solar flares that can drastically affect the planets orbiting them. Now here's where things get even more intriguing. The JWST has provided the clearest view yet of Proxima B, and it has uncovered some startling features. For one, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is in perpetual daylight, while the other is plunged into eternal darkness. Imagine a reality where the sun never sets on one side and the other is cast into an everlasting KN. This tidal locking creates a harsh environment for any potential life forms. The side facing the star Proxima Centauri would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question: could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us, yet the challenges don't end there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is far more active than previously thought. Its intense magnetic fields generate massive solar flares that bombard Proxima B with high-energy radiation. In fact, a flare observed in April 2021 was over 100 times more powerful than any flare ever seen from our sun. Such a colossal burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some experts argue that Proxima B's proximity to its star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life could adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such an unpredictable environment, or is the planet destined to remain a barren rock, essentially lifeless? As we continue to study Proxima B with the James Webb Space Telescope, more mysteries are sure to be uncovered, but one thing is clear: this small planet 4.2 light years away from us is far more complex and enigmatic than we ever imagined. Could it be that Proxima B holds the key to understanding the limits of life in the universe, and if so, what does this mean for our search for extraterrestrial life? Proxima B's stunning secrets were revealed, and one of the most astonishing discoveries was the planet's atmosphere, or rather the potential lack of one. The intense radiation from Proxima Centauri combined with the planet's close orbit means that Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault may have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B could still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which might provide some protection from the stars. Radiation. The James Webb Space Telescope has given us the clearest impression yet of Proxima B's surface, and what it is revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with vast differences. For instance, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland with temperatures plunging to levels far colder than anything experienced on Earth. Yet the most intriguing possibility lies in the narrow band of land between these two extremes, known as the Twilight Zone. This region, where day meets night, offer more temperate conditions where liquid water might exist. The presence of liquid water is, of course, one of the key factors for life as we know it. Could this Twilight Zone harbor a hidden oasis where life has managed to thrive despite the harsh conditions on the rest of the planet? Another startling discovery came when scientists examined the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side or small, possibly transient pockets of liquid water in the Twilight Zone. But the discovery that truly stunned many was the potential for subsurface oceans, similar to those found on moons like Europa or Enceladus in our own solar system. These oceans hidden beneath the planet's icy surface could be warmed by Proxima B's core or by tidal forces caused by its close orbit to Proxima Centauri. If such oceans exist, they would provide an ideal environment to search for life concealed beneath the planet's frozen exterior and shielded from the deadly radiation on the surface. Yet we must not overlook the planet's challenges. Proxima Centauri's magnetic field adds another layer of complexity to Proxima B's environment. Recent studies suggest that the star's strong magnetic fields may interact with the planet's core, potentially generating its own magnetic field. This interaction could help protect Proxima B's atmosphere from being completely stripped away by the solar wind. Much like Earth's magnetic field shields up from the sun's radiation. However, the situation on Proxima B is far from simple. The star's intense flares could overpower any protective magnetic field, leading to sudden and dramatic changes in the planet's atmosphere and surface conditions. These discoveries raise more questions than answers. Does Proxima B have a magnetic field? How strong is it? And how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to withstand such harsh and fluctuating conditions? If life exists, what form would it take? Would it be unlike anything we've ever seen, or could it bear similarities to extremophiles, organisms on Earth that thrive in the most hostile environments? The reality of Proxima B is one of extremes, a hostile world where life faces unimaginable challenges, while the idea of a habitable planet orbiting Proxima Centauri is captivating. The truth is far less hospitable. The James Webb Space Telescope has provided unprecedented insight into the obstacles any potential life on Proxima B would face painting a picture that is anything but rosy. One of the biggest challenges is the planet's exposure to intense levels of radiation. From Proxima Centauri, unlike our Sun, Proxima Centauri is a red dwarf with a much smaller mass and a far more unstable nature. Its powerful solar flares and bursts of energy make it a dangerous neighbor. These flares can erode a planet's atmosphere, exposing its surface to lethal radiation and stripping away the protective layers needed to sustain life. For Proxima B, this constant barrage of radiation likely means an environment that is far too harsh for life as we know it. But despite these challenges, Proxima B remains one of the most intriguing objects of study in the search for extraterrestrial life. The possibility of liquid water, a twilight zone with milder conditions, and the potential for subsurface oceans are tantalizing clues that keep scientists pushing forward. Could life on Proxima B have found a way to endure the relentless assault of radiation and extreme temperatures, or is the planet simply an uninhabitable rock, devoid of life and destined to remain a cosmic curiosity? As the James Webb Space Telescope continues to study Proxima B, new discoveries are sure to emerge. Each revelation brings us closer to understanding this distant world and its place in the grand tapestry of the universe. Whether Proxima B turns out to be a barren wasteland or a beacon of hope for extraterrestrial life, it has already reshaped the way we think about the cosmos and our place within it. Proxima B's story is far from over. With every passing day, the James Webb Space Telescope uncovers new secrets, pushing the boundaries of our knowledge and challenging our assumptions about what is possible. Could this small enigmatic planet just 4.2 light years away hold the key to understanding the limits of life in the universe? Only time and further exploration will tell. Substantially more tumultuous the surface of the star's vicinity to Proxima B implies that the planet is constantly barraged with extraordinary solar radiation, including strong flares that can be multiple times more powerful than those transmitted by our Sun. These flares produce a dangerous mixture of ultraviolet and X-ray radiation that would be deadly to any life form like those on Earth. The impacts of this radiation are not only hypothetical. In April 2021, an especially gigantic flare from Proximus Ander was identified, and it was sufficiently powerful to potentially strip away any atmosphere that could have existed on Proxima B. This event serves as a stark reminder of the dangers presented by red dwarf stars and stirs up doubts about the possibility of Proxima B being a sanctuary for life. Besides, a constant exposure to such radiation would create an incredibly hostile environment on the surface of Proxima B. Any water on the surface would be quickly evaporated, and the planet's rough terrain would be scorched by the persistent heat. The dark side of the planet, while not exposed to direct radiation, would be equally unwelcoming due to freezing temperatures. This extreme split between the scorching days so night side leaves little room for a stable life-supporting environment. The competition to reach Proxima Centauri begins while the signal from Proxima Centauri remains a mystery. The possibility of actually reaching the star system has moved from the realm of sci-fi to a legitimate scientific endeavor. The Breakthrough Starshot initiative, led by a group of visionary scientists and supported by notable figures like Stephen Hawking and Yuri Milner, aims to send small laser-powered spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The idea behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These star chips would be propelled by powerful lasers reaching speeds of up to 20% of the speed of light. The goal is to send these and its planets, including Proxima B. While the challenges of such an endeavor are great, the potential rewards are equally immense. Finding the true nature of Proxima B, whether it harbors life or is a desolate, inhospitable world, could have significant implications for how we understand life in the universe. Imagine if Proxima B, this odd and unstable world, holds the key to understanding life in the universe. The search for extraterrestrial life is perhaps one of humankind's most important missions yet. As we study Proxima B and other distant worlds, we are confronted with the realization that life may not look like we expect. In the end, Proxima B may not be the Earth-like paradise we envisioned, but it could very well be a crucial stepping stone in our quest for knowledge about the universe. The search for life in the universe is just beginning, and Proxima B is leading the way, yet the question remains, can we ever uncover the secrets of Proxima B? Only time and continued exploration through instruments like the James Webb Space Telescope and initiatives like Breakthrough Starshot will tell. Perhaps Proxima B, with its challenges, is not only a planet to be studied, but also a window into our future. The search for life, whether in our own solar system or on distant exoplanets, reflects humankind's innate curiosity and desire to understand the universe. The discoveries made about Proxima B could shape the next generation of space exploration, offering valuable insights into the potential for life on distant worlds. Yet, regardless of whether Proxima B proves hostile to life as we know it, the lessons we learn from this exoplanet could have significant ramifications for other planets out there. We may one day find worlds that are more hospitable, more like our own Earth, worlds where life has managed to survive and thrive in the harshest of conditions. The quest for knowledge will continue, and as we push the boundaries of space exploration, we will likely uncover many more secrets that will challenge our understanding of the universe. In the end, Proxima B serves as both a symbol of the challenges we face in exploring distant worlds and a reminder of the vast possibilities that lie ahead. A planet may hold life, but its importance lies in the questions it raises and the journey it inspires. Through continued advancements in space technology and with instruments like the James Webb Space Telescope, we are closer than ever to answering one of humankind's most profound questions. Are we alone in the universe? The search for life may one day lead us to Proxima B, or perhaps even further into the depths of space. And if we find life, whether microbial or something more complex, we will have taken a monumental step toward understanding the vast, mysterious universe that we are just beginning to explore.